course schedule number 4. So there are a total number of num courses. So this means the courses you have to take labeled from 0 to n-1, and you are giving prerequisites AI and BI, indicates that you must take course AI first and then you're going to take course BI. For example, the pair 0, 1, it means you have to take 0 first and then you're going to take course 1. So the prerequisites can also be indirect. So this means if A is a prerequisite of B, B is a prerequisite of C, and then A is gonna be a prerequisite of C. Yeah. So this one actually it is the hard part of the problem. We're gonna try to find a formula to solve this kind of a problem. Yeah. Normally, if you think about the graph problem, there's a Floyd algorithm. Yeah. So inside the Floyd algorithm, it is a path. It means from A to B, B to C, and then A to C gonna be true. If we put everything inside a matrix by using Floyd algorithm, definitely we have this kind of a formula. And for our problem, we're gonna use this kind of idea to solve the problem. Yeah. Now let's just continue. We are also giving an array queries. So the queries UI and UJ and VJ. So for the this query, you should answer if it is a true or false. Yeah. So if it is a prerequisite, so for example, UJ is a prerequisite of VJ, so we're gonna return true. If it is not, we're gonna return false. Definitely, we're gonna answer all queries. Yeah. So this is so we're gonna call it offline queries. Yeah. It is an offline query problem. But for this problem, it is not so difficult like offline query problem. Definitely, we're gonna do some preparations, and basically this gonna be like first let's just check the structure. So this is not 1 and this is not 0. Yeah, maybe there are others. So for example, this gonna be not 3, and here gonna be not 2, and 2 directed to not 3. 0 directed to not 3. If you see this kind of structure, and basically it's going to be a topological structure. If it is a topological structure, and we are going to check, so for example, if 1 is the prerequisite of 3, but if we know that 1 is a prerequisite of 0, 0 is prerequisite of 3, definitely 1 is prerequisite of 3. Yeah. So we're going to solve such kind of things. Definitely, we're going to use a topological sort to solve the problem because it is a topological structure. And but how can we use topological sort? So for example, we're going to check. First of all, we're going to check this node 1. So for this node 1, we're going to put it inside the queue and we're going to pop it out, and we're going to check this is 0. Yeah. But while we are checking this is 0, because 0 is a neighbor of 1. So if it is a neighbor of 1, so for this node 0, we can build the relationship between 1 and 0. So definitely, we're going to prepare a matrix. So this matrix, it means from 0, from 1. So for example, this is row is 1, and column is 0. Yeah, 1, 0 at this position, we're going to set it to be true. And also for others, if it is like the topological structure from 0 to 3, we're going to set it to true. Yeah. So if we set it to true, so for example, for 1 to 0, if we set 1 to 0 to true, we need to check all other cases. For example, 1 to 1, 1 to 2, 1 to 3. We need to check if 1 to 2, 1 to 3 to be true or not. Yeah. Definitely, we're going to use the what we are giving for this 1 to 0. Because 1 to 0 is a condition. We need to use a for loop to check from 1 to 0, 1 to 2, and 1 to 3. Yeah. Because if 1 to 3, for example, if we wanted to check 1 to 2, yeah. If 2 to 0 is true, 1 to 0 is true, but what about 1 to 2? We are not sure. Yeah. But what about 0 to 2 is true? So for this node, 0 to 2 is true. 1 to 0 is true. So what about 1 to 2? 1 to 2, of course, it's going to be true. So this is why we're going to use a loop we're gonna check all the nodes like 1 to 0, 1 to 2, 1 to 3 to check if it is true, because we're gonna use this as 1 to 0. Yeah, because if 0 to 2 is true, definitely 1 to 2 gonna be true. Yeah. So how can we check? We're gonna check this node 1 to 2, and giving the condition 1 to 0 is true. So we're gonna check it with 0 to 2. If 1 to 2, 0 to 2, yeah, we're gonna check 1 to 2 is true or not. If it is 1 to 0 to be true, 0 to 2 to be true, definitely we can get 1 to 2 to be true. Yeah. Now, if we know about that kind of a formula or that kind of a structure, we can start coding for the topological sort. So the graph and integrate. So the graph gonna be default and fixed with the list, and the integrate gonna be 0 times the number of courses. Now we are going to check the graph. So for AB inside prerequisites, we're gonna build this graph. So for GA, so the append with B and the integrate with this B, gonna plus equal to 1. Yeah. So after building the graph, so we are going to prepare a queue, and I think we're gonna need also to answer the queries. Yeah. But how can we answer the queries? We're gonna use a DP table. 2D table to store the query values, and we're gonna check the values directly. Yeah. So for the queue, it's gonna be the queue. Inside it's gonna be I. So for I, we in enumerate inside the degree. So if this way equal to 0, because it is directed. And we also need to prepare a DP table. So it's gonna be let me set to be, yeah, let me check it to be false or 0. It's the same. So false times the number of courses. So for R in range, the number of courses. So this is just a 2D table. So in the 2D table, we're gonna check from I to J if it is true or false. So for queries U to V if it is true or false. Because finally, we just need to return DP and UV for UV in queries. Yeah, this is our return. So we need to finish this DP table according to the topological sort. Now we're gonna check the queue. So not equal to q dot pop left. Let's just first finish the basic structure. So for neighbor in G with this node, and the integrate with this neighbor, so the minus equal to 1. We're gonna check the integrate. If integrate with this neighbor equal to 0, definitely we're gonna append the neighbor. This is the basic structure, but we didn't build the DP table yet. Now we are going to build this kind of a 2D table. So from where we can build it? So this is a node, for example. This node, let's just use maybe this example is also okay. So for this node, it is a node 1, right? And the neighbor is 0. First of all, we're gonna build a 1 to 0 to be true for the DP table. So from here we can set it. So this means the neighbor gonna be 0, and our node is 1. So this means node with this neighbor, we're gonna set it to be true. Yeah, but we don't know about others. So for example, for this one, so for example 1 to 0, we set it to be true. So what about all others? It is has the relationship with 1 to 0. We're gonna enumerate all other cases. So for example, we're gonna enumerate 0, 1, 2. So for this node 2, we're gonna check this node 2. We're gonna enumerate all the nodes. So we're gonna use another for loop. So for I in range number of courses. Yeah. So we're gonna check this DP. This is our new node. Yeah. So we're gonna check this node with this I. Yeah. So we're gonna check DP node with I. So this means we're gonna check this node 1 to 2, because we are sure 1 to 0 is true. But what about 1 to 2? And what about 1 to 3? What about 1 to others? Yeah. So 1 to 2 is dependent on 1 to 2 itself. Yeah. So we're gonna use bitwise. We're gonna use a bitwise OR to check. So this is gonna be, yeah, because it is a Boolean value, so we can use bitwise OR. It is okay. So DP node with I, so this means this 1 with 2, so it is dependent on this 2 with this node and a node to the neighbor. Yeah. So it is DP I with node yeah, because if DPI 2 with 1 1 1 with 0, 2 with 1, 1 with 0, definitely 2 to 0 gonna be true. Yeah, so this means we're gonna check the DP node neighbor to be true, and then we need to check the DP I to node and node to neighbor. Yeah, so DP node to I. So for example, this I can be 0. If it is 0, it is 1 to 0. It is okay. We've already checked it is true. So it is 1. It is itself. Basically, we don't need to do anything. So what about it is 2? So this means it is DP node to 2. I equal to 2. It means 1 to 2. Yeah. So what about 1 to 2? We are not sure if it is true or if it is true or false. Yeah, because currently we don't have this as yet. So we are going to check this one, 1 to 2. So according to we are going to check 1 to 2 true or false. It can be itself. So 1 to 2 node to I, and we also need to check because 1 to 0 is true. So what about 0 to 2? If 0 to 2 is also true, so definitely 1 to 2 gonna be true. Yeah, so 1 to 0 is true, and 0 to 2, yeah. So this is 1 to 0. Yeah. So basically, we need to check 1 to 0, 0 to 2, and this I is 2 to 0. Yeah, let me just check if it is okay. So this is node to neighbor. Should be equal to node to neighbor. I think it is this 1 to 2 should be 1 to 0, uh, 1 to 0, and 0 to 2, and not I. Yeah, I did something wrong maybe. Yeah, let me just check this formula. Node to neighbor, this is node 1 to 0 to true. Now I'm going to check all the different cases. Yeah, 1 to 0, I'm gonna check all other cases. So 1 to 0 is true. I'm gonna check maybe 2 to 0. I think I'm gonna check 2 to 0. Yeah, I'm gonna check 2 to 0 is true or not. I to not, 2 to 0 to true or not. Yeah, so it means 2 to 1 and 1 to 0. Yeah. I to node and node to neighbor. Yeah, let me just run it to check if it is okay or not. Yeah, it seems it is okay. This means my formula is okay. Yeah, I just need to explain this kind of formula better to let's try to understand why this works. Yeah, let's just try to use this example here. Currently, we are going to check this neighbor. So the neighbor is 0. So this is the neighbor, and this is my node. My node is 1. Yeah. So if we have this 1 directed to 0, so we're gonna set the DP node to neighbor to be true. Definitely, this is okay. Yeah. Now we are going to check all other cases because we are not sure. So currently, we have this node to 0 to be true. So what about this node to 1? Node to 2 is true or not? We have to check because we're going to use this information 1 to 0. So what about we don't have this as? Yeah. So what about 1 to 0? We've already checked. So if it is not, this is 1 to 0. It is true. It is okay. Yeah, because this is just OR. Yeah, bitwise. This is just bitwise OR. It is okay. And now what about 1 to 1? Yeah, but for this node 1 to 1, it is false. It is okay because across to itself, it is false. It is okay. It doesn't matter. Yeah. Now what about 1 to 2? Yeah. Currently we don't have this as, but we're gonna check. So for this 1 to 2, what's gonna happen? So for this node 1 to I equal to 2, 1 to 2, we're gonna check itself. It is false currently, and I to node, and 2 to node. And what is my node? My node is 1, 2 to 1. Yeah. So this means 2 to 1. We don't have this 2 to 1. So currently, this node to I, 1 to 2 is false. Yeah, because we don't have that kind of a structure yet. Yeah. Now, for the next step, we're gonna check if we have this as 1 to 2. Definitely, we're gonna set it to be true. Yeah. But let's just use another example. Maybe it's easy to understand. We have node 1, we have node 0 is here, we have node 0, and here we have this structure of node 2. Yeah. So currently, for our node, for example, we're gonna pop out this node. It is node 2, right? It is okay. This is a node 2. Yeah, so we're gonna pop out this node, and then we're gonna set the node neighbor to 1 to be true. Yeah, and we are not sure about 2 to this is a 0. Yeah, let me make it better. Yeah, maybe use another color. This is a 1, and this is a 0, and this is a 2. So 2 directed to 1, 1 directed to 0. Yeah. So this is a 1 and this is a 2. Yeah. So currently we are checking this node 2. So we're gonna pop it out and we're gonna check the neighbors. The 2, 1. We're gonna set it to true. But currently we are not sure about 2 to 0. It is true or false. Yeah, because we don't have this connection. If we don't check it, we're gonna lose this kind of information. So this is some indirect information we have to check. So now, if we can set 2 to 1 to be true, definitely we're gonna loop through all others. So we're gonna check 2 to 0, 2 to 1, 2 to 3, or all other cases. Yeah. Now we are going to check 2 to 0. We are going to check 2 to 0 if it is true or false. But if we were to check 2 to 0, we're gonna set itself 2 to 0. It is false currently. It is okay. And then we're gonna add I to node. So this I to node, this means 0 220. Yeah, so this means 0. Yeah, I'm not sure if this formula is right or wrong. Maybe I need to submit it. Yeah, this means it is 0 to 0 to 2, 0 to 2, and yeah, I'm not. Let me just submit it to have a check. Maybe this formula is wrong. Yeah, as you can see, it is wrong. I think I can explain it now. Yeah, because this formula definitely it is wrong. Like what I did the drawing, I cannot explain it. Definitely, this formula may be wrong. Yeah, let's try to. This is a 1, 2, 1, and this is a 0. Okay. Yeah. Now we are going to pop out this 2, and we set the node 2 to this neighbor 2 to 1 to be true. Okay, so if we've already set this 1 to 0 to be true, yeah. Now what we're gonna do? We're gonna check this 2 to 0. So this is our node, and this is a 0. We're gonna check this 2 to 0 because we are not sure if it is true or false. So for this 2 to 0, it's gonna be it's gonna be 2 to 1. Yeah, it's gonna be 2 to 0 itself, or with 2 to 1. We already have 2 to 1 and 1 to 0. So what is 1 to 0? We need to find 1 to 0. Yeah. It means it is the neighbor to I. Yeah, because we need to check 1 to 0 because 1 is neighbor. It is a neighbor to this I. Yeah, it is a neighbor to this I. Let me just change it. Not to I, and it is a neighbor to this I. Yeah, now let me just run it to check. Now as you can see, it also works, but let me put this wrong testing case, let me put it inside to check if it works. It is also wrong. It means the formula is also wrong. I set the neighbor. It is a neighbor to node. It is a I to node to neighbor, and this is a DP I to node. Yeah, let me just change a little bit. Maybe it is this. No. Yeah, I forgot. I did something wrong about this kind of a formula. DPI to node, node to neighbor. Yeah, let me just check that. So for neighbor, definitely this is my node, and this is the neighbor. So this is the prerequisite for the node to neighbor gonna be true, and for I, we're gonna enumerate all the causes. So it's gonna be, yeah, I think it's gonna be node to I. We're gonna check node to I. Yeah, let me change it to be DP node to I would add DP node to I 2 to 0. We want to check 2 to 0. So 2 to 0 gonna be 2 to 1. add, yeah, we've already have this 2 to 1, so we only need to check this 1 to 0. So 1 to 0 is a neighbor to I, yeah, neighbor to I. Yeah, but I did something wrong. Even I did this formula like this. Maybe I need to check why I did it wrong. Let me submit it. Yeah, I still get it wrong. I have to check the result why I just get it wrong. So dp not to neighbor. Yeah, I need to check the I to neighbor. It is not to I. Yeah. I to neighbor. I checked the not to I. Let me just check that. So we still have this not 0, for example, 1 and 2. So for this node and 0, we are checking, and this node and 0, it is 0 to 1, it is true. Now we are going to loop through all the cases. Yeah. So it should be we're gonna enumerate all the cases. So it's gonna be I to neighbor. So 0 to 1 is true. Yeah. So what about 2 to 1? Maybe here we have a 2, so we don't have this 2. So maybe here we have a 2. We're gonna check 2 to 1 is true or not. We're gonna check everything with its neighbor, not my node. Yeah, because here I have a node, but I cannot check others yet. It means while for the topological sort, while I'm checking this node, all the previous node I've already checked. Yeah, but I need to check the other node to this neighbor, the relationship to this neighbor. So if this node 2 to this node neighbor, yeah. So I'm gonna check this node with this neighbor. So it's gonna be or. So it means 2 to 1. It's gonna be 2 to 0 with 0 to 1. So 2 to 0, basically it means 0 to 1. Basically it means it is a neighbor to I. Yeah, so it's gonna be dp I, and this is I to neighbor. It means 2 to 1. dp I to neighbor 2 to 1. It's gonna be 0 to 1 and 2 to 0. Yeah, 0 to 1 we already have it. And what about 2 to 0? So 2 to 0 is I to node. Yeah, it is I to node. So I need to change it from here. It is I to node, and here it's gonna be I to neighbor. Yeah, so this is gonna be the right formula. So for example, we have 0 to 1. This is 1, 0 to 1. Yeah, but if there's another node, we want to check enumerate all other node. So what about other node to this neighbor? Currently we have this to neighbor is okay. So what about other node to this neighbor? So what is the relationship with the other node to this neighbor? It means the other node with this node, myself, and node to neighbor. And node to neighbor, I have this node to neighbor. So I only need to check what about the other node, this I, to my current node. So this is my I to the current node. And then I can check all the I to the neighbor. Yeah, so this is going to be the formula. I'm not sure if there are any other formulas, but let me just submit it. This should be okay. Yeah, but let's just check if we can use any other formulas. Maybe this is not. Maybe it is. There are other ways to solve it. Let me just check. So from here, this is we're gonna enumerate this I to neighbor. So can we use I to node? We cannot use, because if we were to use this I node 2 to my current node, so it means our direction have to be reversed, but we don't have this kind of reversed direction, so we can never use this I to node. Yeah, maybe can we use neighbor to I? So this is neighbor. Can we use neighbor to I? I mean 1 to 2. If we were to use 1 to 2, definitely it's going to be 1 to 0, 0 to 2. So this means we cannot use neighbor to I. We have to use I to neighbor. This is I and this is neighbor, because this direction should be the same. Otherwise, we cannot solve it. Yeah, we have this kind of a direction. Now we need to use this direction to solve the problem. So this is a node to neighbor. Yeah. So this is a node to neighbor, and we want to check other node. This means this I to node and node to neighbor. But we want to check this I to neighbor. Yeah, definitely there's only one case. It is only one formula like that. Yeah, we have to be careful about it. We have to check the directions carefully. Otherwise, we're gonna make mistakes. Yeah, it is like what I did is a mistake. I didn't check this direction carefully, because basically we're gonna use this direction. If we were to use this direction, basically we're gonna use this one and this one. So it means 2 to 0, 0 to 1, and then we can get 2 to 1. How can we get 2 to 1? We're gonna enumerate. It means I to neighbor. It's gonna be I to node, node to neighbor. Yeah. And let me just try to submit it again. Yeah, it should be okay. And the time complexity is e plus b. E is the number of edges. It is n squared. It is 10 to the power of 4, and the number of vertices is also 100. It is okay. So the time complexity, let's say just n squared. N is the number of courses. Thank you for watching. See you next time.